So as you might remember, the last time we have implemented some error correction, so that if the file is not transferred correctly, then we can request it again. So for this we use the hash request and so on commands, which we have defined here. And what we will take a look on today will be a new and improved error correction one, where we will not have to re-download the entire file if something bad happens. So first let's quickly start our messenger and quickly see that everything we had working last time is still working. Q messenger, I think the proper argument was profile and then a number, but I don't remember. So let's quickly take a look how our code was working. Okay, so instance. So we need to instance 1. Port 1, 2, 3, 4. Is that correct? Config. Did we set a port? Username. Okay, that seems as it's working. So let's start our. It's compiling, so we need to close it, wait for it to compile, and then we can start the newest version. Okay. Yep. And now we can send, for example, a file. Just retesting everything to ensure it didn't break anything recently. Yes. Test 1. It's working nicely. So what we will now take a look into is how we can better verify the integrity than just through making a hash comparison. So one thing that will be necessary for this, of course, will be some way to artificially trigger an error, so that we then go into the error recovery mode. So here we have hash request, hash response. Hash response is here, and now, right. So basically, what the simplest thing we can do is here to set this to a wrong value, and then we will automatically trigger an error. So let's quickly test this. We will send a file from our test client to our client under debug. Zack, test 2. And now basically here we could just modify the value. We will not do it right now. We will add a switch to trigger an error. So hash and one that only is in place when we are in debug mode. Then the way this works is we can put a breakpoint here, then we can change value of the boolean do fail, and then we can do something with a qt value. Like for example, we can clear this, just remove the value entirely. Qt comes with a extension for Visual Studio that allows the debugger to show you the values stored in their container types, but this also means that you don't directly that you cannot directly easily access the internal data structures of those container types. So there is a little bit of a trade-off. If you would have a C string, it would be super easy to just completely fill it with whatever garbage we want. but here this way we can also implement a nice test case, and of course here then we would get this failure. We'll quickly test whether our test works. So we'll run the thing. Then here we will send again a file. Chat for chat send file test 1. Yes. Messenger test 2. We can overwrite the old file. And now we just do fail 1. Now if we run this, it will say that it failed, and on the other end it will also say that it failed, and it just says bad hash. So it just quits without any further attempts. And now what we will do is here, instead of failing, we will send a request for a hash set, which we already have defined here. We just did not hash set request. Suck. Since we are already in the same connection, we don't need to add any additional parameters. The other end should know what we're asking for, and then there will be a reply with the hash set. One thing that we should also make here is we should note that actually an error happened, so that we always because chat session. So here we have our file hash summary, yes, and we make a full or we could probably make even an enum programming. Hash failed, and so on. So state. Okay, and for our error state, we will set it to hash failed, and here we, as an initial value, will just say that there is an error. So inside this function, where we get the reply, if this is not hash failed, then we can just return and close the connection because something unexpected happened. Let's just return without doing anything. We could of course make this a bit more complex and have another state like hash set requested and so on, but I think for now this will be fine to make it as simple as we can. So what we now of course also need is a handler function on the sending side that will handle the request. So oops. Right. How do we do that best? Do we have the file still open? Let's see. P file. Open. Read position. So at this point we would already have the file closed. But we should have the file name of the file we have been sending. So for now, let's just put a breakpoint there. We run the example and see what information we have at our disposal. I think we'll need to reopen the file and compute the hash set from that. We could, of course, in principle, try to compute the hash set in real time while we are sending the file and then just keep it for later use. That would be also an option, but I think this makes the things less less demonstrative, let's say. So it's a solution, but it's not so great. Also, one more thing: if we get the request, then we are of course on the other side of the communication. So before we start communicating, we need first the breakpoint here, and we need to attach to the other process, so that we can then get into the other breakpoint as well. Right, so now we can start the transfer. The transfer transfers, then we are here, then we trigger the fail. Now we are now we are on the other end of the communication, and right, we have our file still available. We have what do we also have? We have file size, which is no longer valid, or it was never valid. We have file set to 0, hash set to 0, and we have the file hash that we have kept. So at this point now we can terminate everything, and what we will need to do is we need to compute the whole hash set and then send this hash set once it is computed out. One thing to keep in mind here is that this hash set computation may take some time, so ideally we want to do this asynchronously and then send the result once the hash set has been computed. So let's do that. We'll add a new class. Let's call it C hash set. We derive it from QObject as usually. Actually, maybe we should derive it from QThread. I will fix that in a second. I'll just move it to our core folder. Right. Let's derive it from QThread. QObject. C hash set. Thread from parent. Okay, so we have this. Then we should add another parameter, the file name. No, we will use the hash set function from hash set object for multiple things. So we could add here we could have either multiple constructors, because we want to use it for two things: to find an error and to compute the hash set as such. So we can either have like one object that we then initialize with parameters, or we can have an object that has different arguments in the constructor, multiple constructors, so that you can start it and let it do different things. But we will always need a file name, so I'll add the file name here. String. If we decide that we want to change this, we can do it later. Protected QString file name that we initialize as well to our file name. Okay. Now I said we have two options. We have one option is void compute. We want to call it compute hash set, calculate hash set, make hash set sounds best. Right, and this will need a couple helpers. So it will need and contrast and slots. We will want to connect this to a slot later, so that we can emit a signal and effectively put a event from the thread that will be running asynchronously into our main thread, and then send everything inside the same thread as our chat session resides. So we'll need a slot for that. That should be all we need. Yeah. Okay. We will later need also a temporary object to connect it to. Can create it here. Class has a job or task. Has a task. Queue object. As a task. This will not need a parent or anything. Just a constructor has signal. But there will be an abstract task that just has a it will void it will execute, and then we will implement a specific case hash set make task, which we then implement. Oops, this should be 0. The execute function, and there will be a secondary task, not make task, but verify task, which will then also execute, but this time the verification. Both of them will get the file name as an argument, or they will get a pointer to the hash set itself. We will see what's more elegant. This one will need a signal. Find the hash set ready. The hash set computer made, which will return the hash set data. Depending on our implementation, this may be either a simple list of hashes, or it might be a full hash tree. Since we call this hash set, then let's implement this simply, and if we later make something that works like a hash tree, then we will make a hash tree. So hash set made is a signal, and it will get q list q array hash set. So it will emit us a list of with the whole computed hash set, which then will be directly directed to the event in the chat session. I'm just considering whether we should keep a copy on the hash set itself, and that would be probably good. So in principle, we could do it differently. We'll keep this a simple event that it just says that it is done, but the hash set as such will be stored here. For this, of course, we need to define the other classes as friendly, so that we can access, so that they can access here the file name and the hash set variable. And since they are running in different thread, we also need the mutex. Technically, we could use a q read write lock, since we might either only read or only write things, but we always use one thread. So this is a very minor improvement. So in our use case, it doesn't matter, but in other scenarios where we would use a hash set, where we more often want to use it to validate different parts of the data, that this would actually be quite useful to be a read write lock, which allows concurrent read accesses at least. And we'll need another job function to verify the file the file. This will again have a slot. This time this will need a more complex signal. It will of course start our hasset verify task. This will be file verified. And here what we want will be in principle to get a list of ranges in the file which are considered to be to not have the right hash value and will need to be re-downloaded. So here we have a QList, QPair, QIn64, QIn64, and we will call this error list. Okay, why is it complaining? Object. We need of course to define the parent class as public so that everything can be accessed properly. Good. So that much to this. Here our hash set so the way this works is that the QThread has a run function, which, if I recall correctly, internally just starts the exec function, which starts the internal event loop. So we could try to implement this thread without having to rely too much on the event loop. So here we will say that this that execute is actually a slot. Slots, and then we will invoke execute such that it should start in the own thread. And to simplify the debugging at the beginning, we can go to our QMessenger and implement a synthetic test case at the beginning of our function, so that we don't need to go through the whole creating a chat, sending a file procedure each time we want to test whether the hash set is actually doing what it is doing. So we should break one of the files also. One moment please. I will copy it quickly on my host machine, and I have a nice X editor with which I can introduce some errors. So this is FinHex. It's quite nice. We just go somewhere and write maybe here and maybe there. So we have broken the file in two places in comparison with the original. I will now just quickly copy it back into the VM. And also when we think that our file is 10 megabytes in size, so our chunk size to be reasonable should be about 1 megabyte, so that we have like 10 chunks, and then we can detect that 2 of them are broken. Right, and we will of course need the path to each of the files. So let's quickly copy this as well. So we have a good file and then we have a bad file. Bad file is number 2. Cool, and that's hash set. We of course start with the good file because we want we actually should make like a proper test case, because it might be a bit more convoluted. So let's just add another class. Hash test. Okay. And this one just gets a function do test. And this should be static, so that we can call it from wherever we want, and public. Queue message hash test do test, and then we can have everything we want inside there. But we will not pollute our actual main UI window. Hash set it's a hash set good file. So we need to store a few things. So here we'll make a constructor for this, and we'll add another function. Right, and now we just create a new so we create an object. We don't care for cleaning up, since this is a test case which will not get into production anyways. Right, so we can set the hash set on the current object. Class hash set. Set this new hash set. We don't give it a parent. We give it the good file. Principally we could give it. Yeah, we will see where we go from there. So we have the hash set, we have the file, and now what we want to do is for starters we want to calculate our hash set. So that was called make hash set, and we want to give it this and slot on hash made. On hash made. We of course need to add this slot on our hash test. Void on hash made. Oops. So this slot will be invoked. Right. This need to be derived from QObject. Okay. Good. So now we have to think about the insides of this function. So we need to create an object of this type. That's for sure. And task is equals new task. Then the thing will need to get somehow a reference to us. So let's give it just this. Hash set will need here time set set relation p set. Okay, we don't need this. Then we need to add this to all the other constructors. Okay, so this already gets a pointer on us. This is good. Then wait, what's first is connect. Sender, comma, signal. So this is this has set made, comma, connection to target and slot. So what we basically do is the connect function takes just a queue object and a string which characterizes basically which member to invoke. Like here we have receiver and member. We could actually use these names. That will make it maybe more user friendly. So that we see what we are doing. Sec. Okay, so we have made the we need to change names now. So first we create the object in the current thread, and then it automatically is assigned to the current thread. But we want to run it in a thread, which is run by the current object, but this thread run is a separate object. So a queue thread object is supposed to live in one thread, and it runs an own thread, which is a distinct separate thread from the thread in which it lives. And it's not recommended to move the queue thread object into its own thread, but what one can do is one can create objects and then move them to this other thread. So move to thread this, and then we will want to invoke the execution of the function, and later we will want to delete later, which will just dispose the object as soon as the last scheduled slot invocation has been performed. At least that's the theory. So what was it? Meta. The meta object. Invoke method. Object context is task, comma, function with passed, if I remember, as string, so we just give the name. Want to invoke execute, and we don't have any arguments for it, so that should be all. So now of course this is self-contained, this one execute here is missing. We haven't implemented it yet, so we do this quickly, and this will be super trivial because for now it will not do anything. We'll just emit the set made event. We put a breakpoint here. Right, that is the wrong scope. This one is the right one. Set made, breakpoint is set, hash test, breakpoint is set here. Right, so this function should start, run, terminate, and then this should be invoked from the other thread. Let's see if it works out. There is some error somewhere. It might be complaining. Yeah. Oops. Okay, something didn't work out as it should. Let's see what failed. Oh, did we call the wrong function? I think we called the wrong function. It should not be do test, it should be just test. We ran into a Stack Overflow. Well, that didn't work out. I didn't do anything. We might want to move delete later on this to the other object. It might be needed. And also, since we do this, we want to see whether the object gets properly disposed of. So we will add here a destructor on which we put a breakpoint so that we see that this works. Right, so we start with invoke method. And it didn't work, so something we have not done right. It says what went wrong. No, it does not. Let's specify explicitly the connection type. I would assume that this thing should be smart enough to do that. Oh, is it here? No, wait. Yes. Right function, and now outgoing qt queued connection. Right object connection object is this. It should more something is not working. Do I need to specify? Did I mistype the name? No. Copied it from here, and this is a slot, so it should be invocable with the Qt meta object system. Let's see what it's not working there. It should work this way. Why doesn't it this is moved to the thread? Oh, we forgot to start the current thread. That is of course a very good bug. And then we will of course need to stop it once we are done with using the hash set. So let's add a destructor. Quit and wait. So quit terminates the event loop, and waits until it has been effectively terminated. So now we should have everything, I hope. I moved the delete later back to here, since I think that should be, yeah. Now it works as expected. Now we have the delete here, and we have the event here. Wonderful. So this works. What we are now missing is the whole hash calculation part. So go to hash set, and we need a few things, of course, from the get-go before we which we need from the get-go before we can start doing things. We will need to know the file size and decide on a chunk size for the individual hashes. We can either specify this as an argument or compute this dynamically, so I would go with the dynamic approach. Q64 chunk size, which will be initialized here from the file name, but this of course requires the file to already exist. Yeah, let's go with that for the beginning. File info, file name, size, and then we just divide it by 10. That we will always have 10 chunks. This is a simple approach. And then we need also a chunk count. QUint64 file size is the size of the file, chunk size is a tenth of that, and then we need here to do more or less the opposite. Chunk count is equals file size divided by chunk size, but we need to take care for a special case. If modulo 10 gleich 0, then chunk count plus 1. So the idea is that if we don't have so we might have a size of a file which is not perfectly divisible by 10, so we'll get some residual size that is left, and this will be then the additional chunk. So the last chunk can be smaller than the file, smaller than the size of the other chunk, such that the file in its entirety can be properly hashed. We could probably do this a bit smarter here, because currently the chunk size will always be very small, and they will use very arbitrary chunk sizes. We could make it that we, for example, only take multiples of 128 kilobytes, which actually would be a good idea when I think about it. Chunk. Let's do this maybe. Temp size. So we have a temporary size which is a tenth of a file. Then we divide this by 1 to 8. Let's go by 1 kilobyte. No, x kilobyte size 4 kilobytes, which would be the basic chunk size that we want to have. Actually, a good size would be 1 to times 128 kilobyte basic size. So we divide this by this, and then chunk size is then just again this multiplied by this. So what it does is effectively it just cuts off the residue, and now we know that our chunk size is a multiple of this, and then we know that the last chunk will be something reasonable. I think this is nice, so let's leave it like this. We can put a breakpoint here to see what chunk size we end up with finally. Very likely we'll run into the case, since the file probably is not an exact multiple, yeah. And now our chunk size is, how much is that? Looks like it's about a megabyte. 1, 2, yeah, we ended up with exactly 1 megabyte large chunks. Well, that kind of was to be expected, because the file is about a bit under 10 megabyte. It's above 10 megabytes, so we get 10 chunks and then an 11th, which is a bit smaller. Okay, so we have our chunk size, we have our chunk count, and we can start with the execution. So q file, file, and this will be from mpset. We will use a get file name function for elegance. String get file name const. Right, is this the right thing? Yeah. Q read locker. Need to specify the reference, I think. So the object here, the QReadLock, will lock our locker for reading, and when it goes out of scope, it will automatically issue the unlock. So unlike when we manually use a mutex here, we can really easily oops, here we can really easily just one more, please. So unlike using a normal mutex, here we can really easily return a value. So normally, if you would only use the mutex, you would need to make something like a mutex lock, then you assign whatever you want to return to a new temporary variable, then you make mutex.unlock, and then you return the temporary variable. And this procedure can be streamlined very much by using such a locker object, because then it's just a 2-liner instead of a 4-liner function, which is quite nice. Just here we'll finish quickly the other useful getter functions. Might in some scenarios be more beneficial to get all the values at once and then just not relock multiple times, but I think for our use case we just go with the most expedient approach. So we have here our file, then file open q read only. Yeah. And then file close, and in between we'll make a object that will hold our hash set. So we already know its type, hash set. For now we do it on a local copy. We do not compute the hash set for the and write it directly into the main object. Instead we will do this for now for ourselves. So we have here a loop for int e is less, we should cache the chunk count. Get chunk size and chunk count. Okay, so while e is less than chunk count, e plus plus. So for every chunk we want to compute, we'll do this here. And q cryptographic hash. We need to tell it what we want it to be. SHA-256. Okay. Right. So one way, of course, is that we just use read and read whatever we want to read from the file, and then cache everything in memory. But assuming that we have a very, very large file, it would be beneficial to here read somehow in a more smart manner. So since we know that a chunk size is always a multiple of this, then we could read in this chunk sizes. So let's define this. Well, a chunk is a chunk, and what's smaller than a chunk? A crumb. Crumb size. And usually when using sensitive finds, it's always good to put it in brackets so that it will be seen as one entity. So we know all chunks except the last chunk are made out of a full number of crumbs. So q, we will now need to read a few times. So let's see. It would be good to have a crumb count. I hope I wrote crumb correctly. My orthography is not the best. Okay, probably not. That's how you write crumb. Right, so we have this crumb count will be chunk size divided by crumb size. For int j is equals null, j is less than plus, although this loop might break early, so for the last chunk it will. Byte array with crumb data is equals file read max length is crumb size. Now hash punct add data crumb data, and if crumb data size is not equals crumb size, technically if it's less than crumb size, then we break, because this was the last crumb of last chunk. So we break gracefully, we don't error out anything because this was an expected behavior. And now we can finish the hash. So hash set punct append hash was it just hash? No, hash punct I don't remember. Let's see, how did we do it? How did we do it the last time? Okay, so p hash add data result. That's how we do it. Result, and also we might want to convert it to hex. This is usually, of course, not something that we would want to send over network, since it's wasteful. It pretty much doubles the whole the required traffic to transfer anything. But for our use case, since we want to have a mostly text-based protocol, it is nice. So we will just keep it as text, and then we, of course, here proceed to the next and the next and so on. And at some point we are done. So we put a breakpoint here and see if we have computed our hash set successfully. Okay, hash set 11 entries. Yep, that looks correct. So now what we'll do, of course we have here the emit, and then here after we close the file, we will want to set the hash set on our hash set. So void set hash set const and here q write q write locker lock and hash set is equals hash set it is complaining for some reason, but I don't. Alright, we forgot here. No, it should not complain. Yeah. So it's like the read locker just for writing. So it means it will be an exclusive lock and not a shared lock. And that's it. And then it can assign the variable, and it can be sure that there will be no issues coming out of that. So let's well, we could run it, but why? We already know this works fine. So at this point here, right, we wanted to use it npass set hash set hash set let's do it like this. Okay, we have our crumb set hash set, right, and now we have the slot, and we of course need a get hash set function. get hash set is const. That's of course in a read locker. Hash set, and we just return the existing hash set. Right, so this works, presumably. Of the hash set we have our emit, and then in hash text we will end up here having the hash set. Good. So one thing we would probably want from the function here as well is the ability to export it to a file. So we could design some format where we would know the hash size, or we just assume that it will be computed from the file name and that will be correct. For now, let's just leave it, but we'll definitely get a chunk size here. We already have a get function, so this is fine. Probably we'll need a set function in future. Right, and as I said, I think we will change the way this works, so we will remove the file name. Here, instead we will pass the file name when we are making a hash. Make hash set. We will make a set file name, that's even better. File. Set file name const string file name, that's right. File name, right, here we will use set file name good file name. Right, so let's see what we want to change there. We already have set file, and this we will move somewhere else. This computation we will move to make hash set, so that we compute those things. In principle, we could compute those inside the worker, but let's just leave it here. This is fine enough. And then, if we have the hash set, then what we will need is to implement the other part of the thing, so the verification of the hash set. So then we will of course set a file name, and we will set a hash set. And we'll need to specify the chunk size when setting a hash set. So we have the hash set and the chunk size. What is this complaining for? Yes. So maybe we should move the calculation of those things. Yeah, we should move the calculation to our function here. So we have file size, file.size, chunk size, chunk count, chunk size goes away. Alright. Chunk count we have as well, crumb count. That's actually crumb count. Is it? Yeah. Makes it more elegant. So crumb count we have here, chunk size. Then of course we need a chunk size to set here in our setter function. The chunk count we don't need to set because we just see how many entries there are in the hash set list. So we don't need to store that information at all. So let's remove it here. I mean, chunk count could be something like set punct count size file name. That's this we need, but the count chunk size we need, chunk count goes away. Right. And then we have our set set function, and then we have our verify file. And verify file should take a file name as an argument, because in principle we can use one hash set to verify multiple files. Not in this use case, but in general, so this will be more elegant. Oops. Right, so we have here our function, and we go to our hash test. We set the file name. We have the thing. Okay, so we will now create a. We don't need another hash set. We can use the same hash set here. Verify file. No, I changed my mind. Let's keep the file name a global value. So we will just change the file name here. We'll make set file name and set it to the bed file. Set file name bed file, verify file, and then of course like here signal and slot, but here now we will have a different signal. We will have this one. Will that actually work? Not sure if I don't need to define this as a type def before, but let's try whether this will accept it as is, or if we need to improve anything. Hash test. Hash test. Hash test. I think we called it error list. Right, so we should get a list with 2 entries. If you remember correctly, we have broken the file intentionally in 2 places. We have this. There should be a reference. Doesn't matter. This should be fine as is, but now let's do it a reference that it will be slightly more efficient. Zack. Good. That should be fine. So we have hash, we have our verify. Then we can just copy this code here. We will of course need to alter it slightly. We will take our different task type and create a different task type. And of course we have a different slot. This one was file verified. Zack. File verified with receiver and member. Move to thread, execute, and delete later. Nice. So now we just need to create our and we will emit a empty list just to see that the connection here works as well. No, it doesn't want that. Why? File verified. Right, error list this. That should be fine. Yeah, it is not complaining. So let's go back here. So on the hash, we change the file name. We make a verify with the connection and everything. Okay, let's run it quickly. It's always good to test things step by step, because then you quicker can find any potential issues with the code. Okay, so one was finished, so here we are, zack, and then we get there, and then it didn't work. It cannot queue arguments of this type. We need to register the type first. It is of course nice enough that it tells us that we need to do this. So queue has set int my type 1 queue register meta type. What was the type? That was the type. Nice, that will not work this way. How was this working? Queue meta type. One moment, please. Easy enough. Just takes it as a template argument. Let's try it again. It is still complaining. Why? It should have properly registered that. I mean, we can put the registration test-wise here into our test function to call it later, but I don't think this will make a difference. But it says it is not registered, but we have registered it, so I'm not sure why. Apparently something is not right with registration. It says it wants here to have SCD pair, but further up, when you see the definition of queue pair, it's just the same thing, so it should be fine. Queue int. But let's try it exactly as it requested it. I don't think it will make a difference. No. Right, we should give it a name as well, probably. So we will undo this change because it's irrelevant, and call it I forgot the reference. I don't think this will make a difference. But let's try it. Yeah, that this doesn't work. we can remove the references everywhere. Since it's a queue list, it will have a copy on the right anyway, so it should be quite fast to move around. Right, we forgot to move that here. So let's try again. Yep, now it's working. So here we of course get an empty list, but soon the list will not be empty anymore. So if I file, okay, so here we will want to open the file as well, also for reading, and then we will compute the hashes and everything. So let's copy a portion of the old code. So let's see, what do we have. We have our error list, which we'll be returning if there are any errors found. We will want to get the hash set, so list byte array so we get a copy of the hash set so that we have it. We have here the file size, crumb count, but we want to start with the known chunk size, so get chunk size. So let's see, crumb crumb count will be just chunk size divided through crumb size. Chunk count we have. Chunk count just equals size. So we can put it here. Right, so we have hash set, chunk count, chunk size, crumb count is directly counted out of the chunk size divided by crumb size, and here now we can have our two loops. So for Q64 e is equals 0, e is less than chunk count slash I plus plus, and here we have our j. Oops. What should be for our crumb count, and like before we want a hash function. Actually the insides will be the very same, so we can just copy this. Must have duplicated, so we calculate our chunk, but here we don't assign it, instead we compare it. So if this is not equals set size it. So if this is, then there is an error, and what we need of course is the start stop position. So we'll get the file position when we start, and when we end the reading. So stop will be pointing to 1 byte after the position, which is fine. So we just need to know that. We could also make it like point to the last valid entry, but also we have not really defined what our list is, so whether it's start, stop, or start and length. So if we define it as start and length, that will simplify things. Append qmake pair. Start and length is top minus start. Okay, and we emit the error list, and then in our hash test here, now when we run into the slot, we should get 2 errors. And we got 2 errors from this offset. Oh, no, it's fine, because it's always the size of one chunk, which when you think about it makes obviously sense. So technically we could also just return a number of the chunk index which is broken, but I think that if we would want to implement later some other error correction method which has a finer resolution, getting such a explicit error list is probably more convenient. So our hash set passed our tests already. It is working as expected. So we can go to our QMessenger, disable the test, and start using the hash set directly in our chat session. So here, chat session, chat session 8, right? So here we will add it. MP hash set. Okay, and we will need, of course, some of our slots, so these 2. Private slots. Right, so chat session. Let's put them here. For now, maybe we should put them at the bottom. It really doesn't matter, but it probably is convenient to have them here for now, and we can move them later. So right now to the implementation. So we get the request. So now we need, if we get the request, we need to create a instance. Right, we need to include that first. We forgot that. Hash include hash set. Right, so hash set is equals new. Also, if we already got a request and the hash set exists, then we just return and don't do anything. So we have a hash set and set file name file name hash make hash set. We are lazy, so we will copy from here our the rest of our function invocation. Rightio, so this is doing thingies until it arrives here, and when we are here we will want to dispose of hash set at the end at least, and reset this to null, because we got the request for the hash set, we computed the hash set, we sent the hash set back. If we would be using a more sophisticated scheme where we only send a portion of the hash set or something like that, or then would allow the user to request hashes for individual crumbs, then we might want to cache all the pre-computed crumbs from the get-go. But for now we just dispose of them, since we assume we will no longer need it, and if we want something then we can recompute it later anyway. So get hash set list q. Okay. So we have the hash set, we have the chunk size chunk size is equals to get chunk size, right? So now we need to somehow format this into a nice response. This one is the string we want. Has set response, and let's think about it. We would want the hash set, so cool string params for each hash set byte array in hash set params punkt append hash. That is not great. Let's do it better. From right, so hash set von e, and before this, if e is more than 0, then append, let's say, a vertical bar. So our format will be the hash is separated by vertical bars, and then at the end we add a slash or a backslash, a slash, and then we append the number, a number which represents the hash size. In principle, we should specify the file size again, just to be on the safe side. Do we have this cached somewhere? File size. Not really. File data. Along file size, we should just, I think, set, when we start sending the file, set the file size to be the right value. And that's it. Right, then we can then we have the file size at our disposal, so we can save it as well. So the format will be hash chunk size slash file size, or we could something like this maybe. Hash 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 backslash, no, chunk size slash file size, or maybe a vertical bar. It really doesn't matter. We can pick whatever we want. I'm just thinking what would be somewhat nice. Let's go with this approach. Right. So we have chunk size and we have mu file size. Oh, we don't use the file size. We already know the file size. Doesn't matter. Let's keep it here. So now we need to go to the function which will handle our response. This one. We have our split two functions. It is nice. So auto has set data is split two. What was this called? Params, comma, separated is this one from the front, Quatsch, QList. Funky battery hash set. Right, so first comes first, then comes split. At the vertical bars, so and then into hash set we just append the hashes as we got them. Okay. Right, and now we can again split 2. Chunk file size, we split hash set second. Right, and the first one is the file size. No, sorry, the first one is the chunk size. Chunk size is the CF size. First, too long. And for the file size, we don't really care. But we will extract it here just for good measure. And then comment it out. Right, so we did this. Now we can create a hash set and set file name and verify file. Hash set test verify file. We can copy this. Right, and it's running. And at some point it will be done, and it will say that everything's fine, even if we provoke an error. So let's test this test case. So if punct is empty, I mean this should not happen. I mean if one hash says it's wrong, then the other hash must say it's wrong as well. But let's go with this file completed. Where are we evaluating this? We are not. We just send control OK, and then the channel is closed, so this should be acceptable. So here, if it's fine, then we set our file completed to true and send a reply that everything's fine. We were mistaken, there is no error, which should not happen, but well. Right, we have the breakpoint. I don't need this breakpoint. We want this breakpoint for testing, so let's roll. Right, so now we start our second instance. We do everything on the receiver side. We don't care for the sender side. We assume the sender side works fine. Let's be bold here. Send file. Test 1. Yes, I want to receive the file. Debug, we'll call it test 3. We don't want to break our broken file. So we are receiving the file. Now we will generate a fail. When the fail is generated, we will receive the hash response. I will put a breakpoint here. It should think and think and think and send us a response, and it didn't. So something's broken. That's a pity. Then we'll have user declined. Why did I got a user declined message? That looks very wrong. That we forgot something important. Um, in here status field hash set request hash set request. Okay, let's put a breakpoint here. Run it again. Start the other instance. Debug. This time we connect to the other instance as well, so that we can find out what went actually wrong. And we could maybe choose a much smaller file, something that is really fast to send. Yeah, one of the config files. Let's call it test. We'll not even look for the right position to put it to. Right, so we get the request. Whoopsie. Oh, I see the problem. We forgot to initialize the variable. Here. Let's be optimistic. I will just run it without the debug on the other end and hope it will work out fine. Not initializing the variable was a very good reason for it to crash. Okay, oops. Zack. 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 Let's try the big file again. Right, we generate an error. We get a response, very nice. So we got the hash set. It looks correct, let's see. So we have all the hash, and then we have after the backslashes the size of the chunk and the size of the file. That is oh, this will not work. I forgot something important. Right, and here also we get also this. Alright, this error comes when I close the socket, so this is fine. We need to set the hash set. That is a very important step, which I completely forgot. Chunk size. Zack. Right. Let's roll. Right. Test 1, yes. Test. Here we need a breakpoint up there. So we create the error. We get the hash set. We get the result, which is empty, because the file was correct, so it worked. So now the question is how we generate an error intentionally. That is quite easy. We will just use the same method here as we used here to fail the comparison in the hash set. So we will not actually have an error. We'll just say that there is an error. So here, when we compare, here we can hash reset if to fail is active. So this way we'll be able. We need the right word. Right, I need to close it first. Otherwise, it does not. Otherwise, it is not able to write into the file when compiling. Zack. So new chat, send message. Test 1. Yes. So we get the file. We say fail. We don't care for this breakpoint anymore. Now we are here. let's say 1, 2, 3 will be fine, then fail, 1, 2, 3, fail. And now we should have 3 entries. Wait, 2 entries. How many fails did I inserted? Probably 2. With the offsets of the fails. And now of course we would need to somehow recover from this by retransferring only the chunks which are broken. So what we'll do now is kind of like here, we don't care for the hash set anymore, we dispose of it as soon as we can. And we save the hash list. I mean, in principle we could keep the error list on the hash object and keep the object permanently. That's better. Let's do it this way. So we are not disposing of it. We will need to change this a bit. This. Now we kind of don't need to have the type registered anymore. You know what? Let's leave this as is. We will just save the error list on the hash object, on the hash set, and later we will just be more flexible this way. So you'll have the last error list on the object plus the signal will still emit the error list. So that is acceptable. Last error list. Then we'll of course need a get and set functions. Right, so of course we need to change the types then as well. Last error list, and last error list of course doesn't have chunk size, so this goes away. Right. Set. And we forgot to close the file. This can be more compact. Set last error list. Error list and file. I mean the file gets closed when it goes out of scope anyways, but I want it to be closed before we emit the event. So we did this, that is okay. And if I remember correctly, we can in fact connect a signal to a slot which has less arguments. This will just discard them, so let's see if that will work out that way. Here. Right. So we want, of course, our error list. So this error list is equals per hash set punct get last error list. And if this is empty, then and only then we can dispose of all that. So and return. And else we will be now proceeding with re-downloading a single chunk from the file. So basically we would what would we do? We could add a file, add a function. We download chunks. Which we invoke. And the function will again take an error list. We'll check if it's not empty. So if right, how do we do that? We need to know when we have downloaded everything. So one option would be to kind of remove the errors from the error list. Yeah, I think our modification was not the best idea. I will comment this out. In the end, I think we do not want a error list on the object because we want to mess with it. So we'll go back here, re-add the error list to our here, make an own error list copy. Which we then have here. We don't need to write sub error list and error list is equals error list. So now error list is empty, then everything is fine. We download chunk, and now error list is something we can mess with. So if is empty. So if it is empty, then we want to verify if everything is fine. So we have our chunk, so we just make the verify function call here and return. And if this works out successfully, then we fall into this case and we are done. And the idea is now that the redownload function will be always starting the download of only one chunk from the other end. And once this function once this process finishes, then it will automatically call redownload chunks again. And the idea is that when we do this, so each time we do this, before we start downloading, we will remove the entry from the error list. So kind of in advance, assuming that it is correct, or maybe even better, when we are done with the download, then we will remove it from the error list, and then we will trigger redownload chunks, since we don't know if there is something left or not. And then when redownload chunks is triggered and it sees that the list has been emptied, then it means all the chunks which previously have been marked as broken have been redownloaded, and now the file should be correct, so it will verify the whole file. And again, if there are errors, then we kind of just restart the procedure. We verify the file, and so on and so on. There is one issue here, namely that we don't really handle a situation where the file would have been modified on the sender side in between, so that we will get we might get a hash set, and then we get the chunks which will no longer match the hash set. So theoretically, we should maybe re-request and reinitialize the hash set after the download of the broken component parts have been finished. But I think this adds too much complexity. We should just assume that the file will not be modified in the meantime. We could of course also keep track of which chunks have been broken in the past, and if we later on, and if we get a few times an error, then we will at some point abort. So we should not try to re-download the same chunk over and over and over again when it fails. I think we will generally here just make a counter which will count how often we have restart a verification, and then just abort after 3 failed attempts. Recovery counter is null, and each time when we verify file, for the second time we will increase it. And if recovery counter at some point will be on file verified, so here if verify counter, actually we should do it there. So if verify counter is, so if plus plus verify counter is bigger than 3, then we say that something is not recoverable. We tried 3 times and we failed. What do we have? The error. Yeah. We can just bug out with bad hash and return. This is reasonable. This is a reasonable approach, and it's very simple. So very good. So now we are missing only the redownloading logic. So when we look here to our functions, we have file data, we have accept, decline, and so on, but we don't really have a option to request file data. So hash define ctrl msg get chunk chunk get, and then there will be a reply chunk data. Get chunk. Now let's name it like this: chunk get and chunk data. Right, and now we need to implement them. So our chunk get will specify just the starting offset and the length, and that's it. So hash set rest, so here, zack, chunk get, but first we need to format, of course, and then we also need a chunk data data block. So let's first start with implementing the chunk get. So redownload chunk string params basically is equals to our list first punct first qstring and plus vertical bar, the same with the second. Offset and size. Yeah, let's go with offset and size. Plus second. Okay. So we have here our request. Let's see how we will handle that. It would be very similar to the handlers of the accept call. Right, and of course if we say that we accept what we set, what are all the things we set? So we have here send accept. Right, we need to open the file for writing. File accepted, we don't reset this, right? Yeah, but we will need to open the file for writing. We will not make file hash again. Okay, so we make this and then it comes further down. So file gets open. This is just return. And it's not write only, but read write, because we don't want to overwrite the content, so we make read write. Now our acceptance handler. Here, so if we have the accept, we just make a send start send file. So do we need this actually anywhere else? Not really. Now let's keep it here. But we will need to specify how much we want to send and from where. So start send file, int64 pos is null and int64 len is -1. So -1 indicates that it is everything. So we just use start send file here in our here, but we need to first split the data apart so that we get the two values. So params, we used a vertical bar if I remember correctly. That is pos len, position and length. And we pass pos len to our file. Right. We forgot an important thing. Here before we started the file, we need to go to the right offset. Set position, seek to the start position so that we start writing the file at the right offset. Right, good. So we did this, now we do this. Right, so if pos is 0, so only when pos is 0 we initialize hashing, otherwise we don't. That could be in principle a separate function, but well, this is fine. File open, file seek to pos. Yeah, and continue sending file. We are sending the file until we reach the end, which is not good. We want to stop when we are, well, we want to stop when we are done. So I would say we make if len is equals -1, then this, else file size is len, so we just set the file size to length. Alright, but then we also send here a file data, but we don't want file data, we want the other one. So this should be improved later on. This is not elegant because we just changed this here to chunk data. Specifying the size again is okay. We open the file and we seek where we want to seek, and then we start transfer. Okay. The problem will be on the receiving end, that there I think we also are just looking on the file size, but here we want to do kind of this recovery thingy. So we should maybe introduce a new variable, not file size but transfer length. Mu transfer length. Alright, and we should initialize this with something. Right. File size can always be file size, but depending on what we do, we send either this or that. Right, with file size or with transfer length, because this is chunk data. This means that we will need to improve on transfer length, but we can also here copy this and go to our chunk data handler. So of course, if it wasn't accepted and returned, that is of course clear. Params start file size. We don't want to change file size. This is now the transfer size. Pending file data is set to true. Right. Right. Okay, so continue file transfer, and here we're kind of going until the end, and we don't want that. We want to break when we are done. Right. Transfer size must be file size. Because that's how far we want to go. And if we do this, yeah, this is okay. Yeah. Oh, and we are missing also one thing. So if we are done with that, will be for later. That will be for later. And hash failed. Get a new stage here, re-downloading. Which when we saw the verified file, re-download chunk. Right there, here we go. This is then error state re-downloading. Yes. Send file. So we have here our chunk. Right. The first thing to fix is this one. So file buffer. Size file read. Buffer size always tries to read buffer size. So we should make here a variable int to read is equals let's start with buffer size, but if to read is more than transfer length, position length minus file position, file pos. So if to read is more than where we want to go, then we need to change to read is equals transfer length minus file position, and then we read to read. In principle, if to read is equals null, then we can break as well. So here we break because we are explicitly done. Here we break on an error, and hash might not be defined. So if hash, then hash, is this set to 0, this set to 0. Right, and hash on bytes written. Right, on bytes written. So when we have sent something, so if hash, otherwise we don't do that because we already have the hash. And here we are just completing the file send procedure. Good, that looks reasonable. That looks reasonable. Send the file. The accept. We won't accept here. We open the file. We did not create hash, so this we have we download without creating the hash. Okay. So now we need our onReady read handler, and here file data pending. So hash and add data if hash, because it might not be. Again, if hash, because it might not be, and per file size, per file size, haha. Transfer length. Now we need to ensure that we will detect that we have got all the data we asked for. And in the past we did this just by comparing the size of the file with the size we were told the file should have when it is completed. But now it's different in as far as that we have here the file already at its full size and are just writing at different offsets. And our transfer length was only the length we want to transfer, so the amount of data we want to send. Oh, we have a bug. We have a bug already in the code. I think here, yeah. New transfer length. It should not be transfer length. It should be like transfer stop, and we need to change the value. So let's say transfer end. Call it transfer end. This is chunk data. We'll need to have multiple information, so this will add later. So transfer end is file size, and transfer end here is position plus length. And as length we will send transfer end in the end. Okay, so we have this here. When we have the transfer end, which is okay, we receive the transfer end offset, and we have set. This is not very fail-safe, so we should improve the protocol a lot, but just demonstrate the principles. This is fine enough. onReady read. One bug. Transfer end, and then we need to set this also for the normal case. So file size and transfer end is file size. Right. So we have here our transfer progress, position, file size. This we don't care. Size is not size but position, because after we've written the data, the position has been incremented, so that will be fine. Right. It should work. Hopefully we didn't break anything. First we will just try file transfer to see if everything is still working, and then we can try. We forgot also something important, to request the next chunk. Oh, and we have a bug. That's also. No, we might not have a bug. It's just we didn't close the other window. Okay, so we start the other instance. Send file, test1, yes, test, yes. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, not right. We broke something. We are just transferring and transferring and transferring data all the time. That is very wrong. So first of all, end transfer here. We have a why is this wrong? So first thing here, probably that we are like one past this. So this is not good. First we'll cache the value here. The file position, and then if position is greater or equals transfer size, obviously. Yes, then we put a breakpoint here. But the sending side seemed also broken, so let's see why is that. I know why. Because here we need to resize the buffer and then we check whether it's empty. So if this is, so let's see if this is greater 0, then we do this, and read is, and else read will be 0. We were sending the last block over and over and over again. That was not good. Actually, that might just be fixed. Let's see if it works correctly now. Right. We start our other instance. We send our file. Yes. Oops. While is file null? It's a new bug. Didn't have this one before. Let's just restart and try again. File is null. Let's try saving it under a different name. Maybe something is locking the file we always use for testing. And if not, then we just, I don't think we actually created a new bug. I think we just ran into a bug we always had, which did not manifest before. Test 1. Nope. The bug is reliable. Why? Right, so we have here accept file, and what do we have on bytes written? Weird. So new chat, send file. For some reason we are just closing the file far too fast. We open the file, which is correct. Oh, and then we run into this. Per file buffer is empty. Continue central, but we are not in the business of sending a file. On this end we are in the business of receiving a file. On bytes written. Yeah, that's a bug. In principle, we could just go with that file offer must be true. We don't reset this either. We just set it to true and then we keep it. Yeah, that is acceptable. So, well, basically a file offer must be open and this must be true for us to continue. So, I'm not sure why we are triggering the error now, but I think it was always there. We never checked. Here it just was some combination of circumstances that made this not fail before. Let's send file. Test 1, yes. Test 1, yes. So we get a new file, and then we have the file here, yeah. Position is 0, position is doing something. And then we are done with the exact same value. So having this equals would have been fine. Is it fine though? Let's see, this is here and there. Test 1. Okay, this is working perfectly. So now we can try the error recovery. Sorry. We need to send the file again. File 1. Yes. File 1. Yes. We don't need this. Now we want to initialize a fail. Now we want, yeah, no. A few chunks are fine. One chunk is broken, the next chunk is broken, and then the rest of the chunks are fine as well. And it's not doing anything, so something's not right. Well, we assume. Oh, we didn't went into here. Do we have a bug somewhere? Ah, yes, we have. When we were editing the code around, we forgot to re-add. Oops. Re-add this here as an argument. So our connection is wrong, so we need to restart it and test again. New chat, new message. Test 1. Yes. Test 1, yes. Fail. 1, 2, 3. Right, so we enter our error list with one error this time, just for simplicity. Error count should be 0. Right, so we go to redownload chunks. We will make this get chunk request, and then we'll end up here in chunk data. I hope we do. Then we go here, and transfer is somewhere. Pending is false, so we right. So we got the data, and of course we forgot to finish the implementation here. So when we end the transfer, we need to check whether we are in the error recovery state. So if if error state is equals, well, it's not equals none. Let's say if it is equals redownloading, that makes most sense. So if we are here, then we want to simply redownload chunks. Actually, there should be redownload next chunk. Doesn't matter. Right, so here then we finish this, we do that, and then here we are then at some point done. So we would then drop into this once the list is exhausted. Let's be optimistic. It might be already fully functional. Zack, chat, send file 1, yes. File 1, yes. We'll now break 2 chunks. 1, 2 is fine, 1 is broken. 2 are fine, 1 is broken. And the rest is fine. So here we have 2 entries. We do. Zack. We start with the data. That was a bit too fast, wasn't it? I want to see this. The other one, that was very fast. Might be correct, I mean this is just 1 megabyte that we are re-downloading. Chunk data, download chunk data. Oh, we forgot an important thing. We're now re-downloading the same chunk over and over again. We forgot to remove the chunk from the list. List punkt. Hello, remove first. Yeah, there it is. So we kind of are optimistic that the error is gone, and then the chunk will do the retesting. Yeah. We could in principle add a synthetic code that always throws errors on chunks with a given number, but then I think this would not be that much better, since we would need to be able to enable and disable it anyway, so that we can on the second go through have a full success. Chunk 1, yes. So we transfer all the 10 chunks, then we fail the file. 1, 2, first 3 chunks are okay. We fail the 4, 5, 6 are fine. We fail 7, 8, 9, 10, 11, 12 chunks. However many. We have our 2 errors, which is nice. So we continue. We go into this, we go into that with 2, we continue, we go into that with 1. Okay, so we download both chunks, so now we should verify the file. We do. This time we don't fail the file. No, we don't fail the chunk. And here our list is empty, so the transfer was successful. And voila, we have a smart error correction, at least smart-ish. It could of course have been made much smarter in many ways. So for example, we could not rehash the whole file, but only check the chunks we have re-downloaded and stuff like that. but I think for the general use in a simple chat application, this is already probably much more than any other chat application I ever had. They, I guess, usually just transfer the file and then check the hash and then expect everything to be fine. Now, since we are running out of time for today, that is a very good moment to finish the lecture. I will upload the new version of the project and the recordings to the Moodle, and we will see each other next week. Bye bye.